Hi, so today we'll be working on the same code. We'll be adding the exceptions that I forgot to add. So first, just see the previous video if you haven't watched that. We were doing an implementation of a linked stack of generic type T, and we just forgot to add an exception class. So first, I've already created a new class, so it's called empty collection exception. So create that, and then you can pause the video and create it, and then come back. So it's just public class empty collection exception extends runtime exception. So empty collection exception is a runtime exception through inheritance. And then here we're just going to call the constructor, so public empty collection exception. So it's going to pass in a string collection, so just a string variable. You can call it whatever you want. Then here we'll just call the super reference and say super the plus collection the plus collection plus is empty. So that's it, just save it. Then we'll go back to the links class. So in the pop method here, we'll just add something here. So we'll say, I think it's just if one sec, let me just check. I think it's just if is empty. So if is empty, when you call is empty like that, it's just asking if is empty returns true. Then we'll throw new empty collection exception, and we'll pass in linked stack. And here you can also say throws empty collection exception if you want. So what that's doing is, all it's doing is if you pop a linked stack that's empty, then it's going to throw an exception. What you also can do, if you don't want it to cause an exception, is you can just comment this out, and you can write here, you can write system.out.print line, and you can just say the linked stack is empty. Whoops. And then you can return null here if you want. That's another option if you don't want an exception to occur and to mess up the flow of the program. It's just up to you. But if you want, I also do this sometimes when I'm handing in assignments, and then I'll just comment that out and put optional. Optional to throw new exception if you want to, because if you do that, the flow of the program is going to stop, and it's going to go into an exception state where the program basically crashes. But in this way, if it does throw an exception, you can just write that the link stack is empty and return null. So it will never hit these statements, and the next statement will occur after this method. So you can do the same thing here. We can just copy the same thing, paste it here, and it's up to you whatever you want to do. Sometimes your professor might ask you to, if you're in school, they might ask you to throw the exception. Others won't care, and others will just be like, it's up to you whether you want to throw it or just return null. Usually both things should be fine, but maybe you might want to include both just in case, so they don't take marks off for no reason. What's that there? Okay. And we'll just put that right here. You can put else if you want, you don't have to because it's the only option. You could say else return, but you don't need to, that's fine, it should work. Just run it to make sure. Yeah, it works fine. I think that's what it was. We don't need anything for a toString. Size is empty. The only ones are pop and peek, because if you're peeking at an empty stack, then if you return top.getElement, it will probably throw a null pointer exception. And also, if you want, we can add try and catch blocks here. So try that, and then we can just catch a few things. We'll catch null pointer exception E. E, you can name it whatever you want, I just call it E, so it's null pointer exception object E. Here we'll just say e.getMessage, which just prints out a message about the exception. And then we could say e.print stack trace. And you can system.out a message to the user if you want. There's other exceptions you can catch, but we'll just catch one. And if you don't know what a try and catch block is, you can see the previous videos. I think I did videos on it. But all it's doing is it's going to try these code statements, and if an exception occurs, it's going to catch it. But if you don't have the try and catch, then the program could just crash, and with this you can handle it into continuing. But at least that way you're catching and handling it. So if you don't write anything here, you could just system.out, because that's pretty much what happens when an exception does occur. It automatically prints a message and prints the stack trace. But you can just system.out that an exception occurred, null pointer, and you can just return or something. You can just that's it, or you can continue with something. And there's also a finally clause that will execute for sure. You can add that as well. So that's it. And in the next part we'll be doing the diagram. Okay, I'll see you in the next part. So today we'll be doing the diagram on linked stack on our data structure, the LinkedStackADT. So I'm going to try to do this in a different way. Because I usually do it left to right, but I'm going to try to do it bottom to top. So first we're going to start with, we're going to be working in Paint. So we're going to create the nodes. The first node we're going to have to create is, so the code is available in the previous video. See the code. I'll try to upload it to GitHub if I remember. So we're going to just create we can put the top node here in the left corner, something like that. So just create a box and then put a line through the middle. And then we have two fields, remember? Two instance datas. Or datas, yeah. So we'll say, remember each linear node, because this is a linear node top. So each linear node has two fields again. Element and next. So we'll just write a linear node, of generic type T top. So that's our top variable, object reference variable. So in main, I think we push 5, 6, and 11, so we'll just do that. And then we'll remove 1 or 2. So we're going to go to, linked stack of generic type integer, linked stack in lowercase equals new linked stack of generic type integer, empty parenthesis, semicolon, and then linked stack dot push 5. So I'll just write it here, I guess. So linked stack integer so integer is a wrapper class for int. Then we'll say linked stack. We'll just call our object linked stack in lowercase. Yeah, that's not gonna fit. Can we move this whole thing over? Linked stack integer and linked stack equals new linked stack. Whoops. Integer empty parentheses and semicolon, then we'll move it back over. Make it smaller. Okay, that's it. Can't move it anymore, so then we'll say link stack dot push. Linked stack dot push. We'll push the integer 5 just as an example. The same one from the code. So first we will choose the box again. We'll start with the bottom. Oh, I guess I won't start that far down, but we'll start like around here. Okay, so before that, so link stack dot push 5. So go to the code and you'll see public void push T element in the link stack class. So we're going to first execute the linear node of generic type T node equals new linear node of generic type T parentheses with element, the parameter element. So we'll create a linear node here. This is what's going to happen. We're creating a node, right? We're going to set it up the same way with element and next fields. So element, next, doesn't have to be perfect, just whatever. And then the name of this is node. You could just call it at like 1 at 1. That's fine. So the element we're adding, just a 5, right? Actually, I'll just do that again. 5. So we're going to execute the next line now. Actually, we'll just go back for a sec. So what we did here is we created so let's just execute the first line of main, which was we created this object here, link stack integer of type integer, link stack equals new link stack of type integer objects, right? When that happens, we're going to go to the constructor for a link stack. And remember, link stack has 2 global variables, private int count and private linear node of generic type t top. So I'm not going to write count here. That's fine. We're just going to focus on top. So here so in the constructor for link stack, it's public link stack, and then count is set equal to 0, and top is set equal to null. So how I'm going to write this is like this. So we're going to have, maybe here I usually put the null here, or like here. We could do it over here. Yeah, let's just do it over here. So create another node. It doesn't have to be a node, just a box, right? And inside we'll just write null. That represents our null. So then we'll take, so now we'll go back. So we'll push 5. We've called push 5 in main right here, link stack.push 5. So then we've created linear node of generic type t node equals new linear node of generic type t element as a parameter. That's right here. We've created our node. It's called at 1, so it's node 1. The memory location is 1. So that line was executed. Now we're on the next line. Node.set next to top. So this is our node. Oh, sorry, before that, we set top equals, or top points to null. So let's just start again, just to make sure that we're on the same page. So in main, we have this line right here. We're going to instantiate it, our link stack. When that happens, we're going to go to our constructor of link stack. We're going to set count equal to 0, that's fine. And then we'll set top, which is this node right here in the top left corner. So top points to null. So what I do is I take that middle part of the box and I point it to null. Right? Or like that. Whoops. So the middle of the box is pointing to null. Now I'm going to take the element field and point it to this arrow. Or just kind of, yeah, that's fine. And take the next field and point it to this arrow as well. So they're all pointing to null. But technically, you can really just take that arrow. It's going to get messy though, because there's going to be tons of arrows. Especially if you're doing like 5 objects or more. And we're going to be erasing them and stuff. So if you take this arrow, what it's really doing is it's also pointing to null like that. And then the next field is also pointing to null like that at this point, because I think what happens, like the best way to think about it is when we set top equal to null or top points to null, then all of top points to null unless specified, right? Unless we're saying top.next points to this, or top dot element points to that. right now if top is pointing to null and these fields aren't pointing to anything, then they're all pointing to null now. So we'll just kind of put it like that to save space. Or like this. Actually, this one's fine. So element, so our whole top node is pointing to null, including element and next. We could double check that when we debug it. Or you can double check that if you debug it, but it should all match. I might do just a check later, but I'll have to compile the videos. So that's fine. So then we're saying, so after that, that line is executed. So now, so now the constructor is set up. So now we finished this one. That line is executed. Put a check there. Now we're on this line here. LinkedStack.push5. So then we're in the push method now. We've gone to the push method. We say linear node of generic type T node equals new linear node of generic type T. Pass element as a parameter. That's this node right here. We've just created it. And we pass 5 as a parameter because that's what we passed in main. And then we'll say node, which is referring to this node, node 1, dot set next to top. Node dot set next. So take this next and point it to top. I kind of wanted to do the arrows from here. Maybe I should, because it's going to get messy. So I'll just erase these. You'll see what I mean in a sec. So I'm doing the same thing. I'm just going to do it from above the name here. So I'm going to take an arrow like that, point it to null, and then take that arrow, point it there, and take that arrow, which is following this arrow here. So it's all pointed to null. So I'm going to take next right here, and we're at next dot set next to top. So next, set it to top, which is here, which is actually pointing to null. Because look, where is top pointing? Top is pointing to null. Now at this point, we're saying this node 1, node dot set next, node dot set its next pointer or its next reference to top, and top is currently pointing to null. So technically, this is really just pointing here to null. So the way I'm going to do that is I'm going to take this right here, take it through here, like that, take it even through the middle, come through there, like that. Whoops. Right there, pointing to null. Its next reference is pointing to null because its next is pointing to top and top is pointing to null. I should have pretty much joined those arrows, but that's okay. It's kind of messy though, so maybe we could do it from the back, because there's going to be nodes coming here too. So we'll just go like that. There we go. So it also points to null. Okay, so I think that might stay like that all the time because this is the bottom element, and the next reference is actually a previous reference. Technically, we discussed that in the previous video because it's pointing backwards. So then now we'll set top. So top equals node now. So top points to node. So now top is no longer pointing to null. So we'll take the eraser and then erase these arrows here. Whoops, and I ruined the name. So just like that. This is the way I learned it, at least just by trial and just by practicing these diagrams. It'll really help you understand linked implementations, linked data structures. So now that's it. So then count plus plus, we could write here like count. Count initially equals 0. So then we say count plus plus. So count equals 1. Just put plus plus here. So count equals 1 now. So now we'll go to main. And we'll do the same thing. We'll push 6. So link stack dot push 6. Push the integer 6, or the integer object. Just like that. So we'll do the exact same thing. Whoops. So choose the shape thing, square. So then so now we're at the push method. Right here, link stack dot push 6. We're going to go to the push method in the link stack class. So linear node of generic type T node equals to new linear node of generic type T, passes an element as a parameter. So right here we're just going to create another node. Doesn't have to be perfect. Then we'll just put a line through the middle and create 2 fields again. Then put a next field here. Then we'll add 6 to our node. That's it, that's done. And then we'll set, oh sorry, did we forget to set top to node? Yeah, we did. So we could just draw the arrow from here again. So top. So just sorry, step back for a sec. So we will go back to this node here, and top points to node. So top here points to node like that. So top's element and next will also point to this main arrow. So top's next and top's next and top's element are all pointing to top.element, and top.next is all pointing to top equals node. So top is pointing to node right here. That's why I take it directly from the middle of the box to show that it's the whole thing. Then I'm taking these fields and I'm pointing that to the big arrow, but what's really happening is they're all pointing to node 1. So right now our top is pointing to this node right here. So now we'll go back to this one. So that one's done. Link stack.push 5, that's done. Then we'll do link stack.push 6. We're in that. We've created the node here, instantiated our new node object. We passed in the element 6. That's done. then we're saying node.set next to top. So right here, the next reference here is going to get set to top is pointing here. So like this. I'm just going to point it like that. Right there. Our next is pointing to top. And then top now points to this node. Sorry, and we'll name our node here as well. So we'll just say node at 2. Memory location 2. Then we'll erase our old top pointer. Excuse me. So we'll just fix that arrow quickly. So the next of this reference of our node 2 is set next to top, which was pointing here, and now top points to node, the current node. So when it says node, it means the node that we just created. So now top points to right here, like this. Because remember, this is the next arrow for this, pointing to null. So we'll take this top, we'll take top and we'll point it to node that we just created, so like this. Right there, like that. And we'll have the fields kind of connecting it like that again. So it's showing that element and so top.element and top.next are all pointing to node 2. So top points to node right here. That's our top element. This here is our top element. Current top. And before it was this one. So right now this is our top node right now. So that's our link stack. 5's on the bottom, 6 is on top. And this is top because it's the top. We've set it that way. So then count plus plus, count equals 2. That's fine, and then we'll just do one more. So linked stack dot push. We'll push 11 onto the stack now. So we'll do the same thing. We'll go into main. This is our pretend main, but you can go to the actual code. So link stack dot push 11. We're going to go into the push method again for in the link stack class. Looks like we're going to have some arrows through our node here. So we'll first, in the push method, we're going to execute linear node of generic type t node equals new linear node of generic type t. Pass an element as a parameter, so we'll just do it like that. I guess I can just put it up here. Then we'll put a line through the middle. add the two fields, element and next. We'll add our element, 11. That's done. So 6 is done and 11. Actually, we're not completely done. We've added the node. We've executed that first line. We passed an element as a parameter. Then we'll say node, which is referring to this one, which we haven't named. We'll name it node at 3, at memory location 3. So we've created our node. When we're saying node.set next to top, so where's top pointing? So top's currently pointing here. So what's technically really happening is it's going like this. It's going to connect with this arrow here, and where is it pointing? Right here. Well, we'll just draw it on the side. That you can do it that way too. It actually works better, but then we're going to have to erase this arrow, So node.set next to top. Node, which is it's referring to node at memory location 3. Dot set its next reference to top, and top's currently pointing here. So we're just taking our next reference here and pointing it right to top, where top is pointing like that. And then top now points to node, and node is referring to this one because we're still in the method, and the node is the only scope. The scope that node's referring to is this node because it's the only node in the method, in the local method. So then we're saying top now points to this node, not this one anymore. So the top is now changed to this one, this node. Whoops. So we'll just erase this. We won't have to erase the whole thing. We can just go like this and just point it like that. Top is now referring to this node. And next refers to this one, and next refers to that one, and that's our link stack. This is the top now. You can see this is the top because top's pointing here. And the very bottom element of the stack's next reference points to null, because there is no next, or there is no previous technically. That's why I said it's previous, because it's pointing backwards. Well, or I guess you can think, or you can look at it a different way and say that in a stack's next reference points backwards. But it kind of makes more sense to think of it like a previous reference. So top points to node now. Top.element and top.next all point to the same place right here, which is pointing to node at memory location 3. Then count plus plus count equals to 2. I'm sorry, count equals to 3 now. 1, 2, 3. So now we'll just we will pop an element or 2 from the stack. So just have take some water here. Take a sip of water. Excuse me. Okay, so now we'll go into the pop method. So we'll just call pop here. Linked stack dot pop, no parameters. So we'll go into the pop method in the link stack. So if is empty, so it's not is empty, so that's false, to get skipped. So linear node temp points to top. So we'll have to create a new node here. Technically you don't need to, but you can put the fields in. Whoops. Because for these kind of nodes, it's just pointing to the arrows anyways, unless you set them differently. We'll just write it in. So element here, and next, and then this is called temp. So we're saying when your node temp points to top, so there's two ways you can do this. You can just point to where top's pointing, or you can just connect the arrow like this to connect to that arrow like that, and you can have these like that. That way you can tell where the exact path is. This way shows the exact path that temp's pointing to top and top's pointing to here, but technically temp's just pointing straight through from temp to top straight to node 3. But that way you can see temp is pointing to top, top's pointing to node at memory location 3, so temp is just pointing to memory location 3. And the reason why that is, if top changes, it's still pointing here. It still has a path to, that's the way it works. So if once top changes, temp is still pointing to memory location 3, so this arrow is still there even though top can change. Now, if top starts to point here, top may change, but temp still has a path to node at memory location 3. So that's all you have to know. Excuse me. So the way I really thought about it was, or the way I learned it, was I'm just saying basically temp now controls top, but we'll work on that later. Because right now if you say temp equals to null, then basically top is going to change to null as well. Because temp's pointing to top and is pointing where top is pointing to. But we'll work on that later. We'll do an example because that's going to get more in depth. So we'll just start off with this for now. We have a direct path to node at memory location 3. And then we'll set t result points to top.get element. So t result points to top, which is pointing here, .get element, so it's pointing to 11. Top now points to top, which is pointing here, to node at 3.get next. So top, which is pointing to node 3, now points to top, which points to node 3.get next. So now top is actually pointing to this node's next reference. Basically like that. But we can do our own arrow, just in case that one changes later. So it's like this. So top is changed to this one. Then what we did, or what I did, is I changed, well I guess we did it together. But I changed the code initially, so it was, I set temp, which is pointing, which still has the path here, to the old top. I guess we could have had it pointing, since top changed, basically we can just think of it that it's pointing like this, right? So temp's pointing all the way around to node 3, and we're going to set temp, which points to node 3. So that's the example of how it controls, because we've set temp, initially we set temp to point to top, which was this before, node 3, top was here before. So temp was set to top, to node 3. It points to node 3, which points to the location. So basically the way I thought about it is that it controls, this temp variable is actually controlling node 3 now. Because now look, we're going to set temp equal to null. So now temp points to node 3, and now node 3 actually just points to null. We've kind of got a lot of arrows now, right? So basically temp points to null, so temp's pointing to node 3, and then now it's pointing to null. So you can basically just point like that to null. It's confusing to understand, but you just have to think of it like that linear node object reference variable temp points to top, and then we're going to set temp to null. So we're going to change the way where top is pointing to by setting temp to point to null. It's actually controlling this one. So now they both point to null. So if it points to null, it would be eligible for garbage collection. We can erase it, or we can just, if it doesn't point to an object anymore, then basically it's erased, so we'll just erase it. So this one gets erased from the memory. And then temp also points to null, so basically temp's going to get erased as well. That's why it's a temp variable. That's why we called it temp, because it's going to get erased from the memory as well. But that's how you do it. And then count minus minus. So count actually becomes 3. And then we return result. So that's all what we're going to be working on. The reason why temp pointed to this node at 3 that got deleted, and how temp was able to take 3 and point it to null. You just kind of have to think of it like that. It's now controlling that variable because it's pointing to null. Sorry, it's pointing to the node at memory location 3. So the best way to think about it is just that now temp now controls the node at memory location 3. So when you set later on temp to null, then it's going to change the node at memory location 3. It's going to take that and also point it to null. We're gonna be working on that later, but just think of it like that. I'll see you guys next time. Take care.